Hi, so for today we're going to talk about integration by parts, the tabular method or the shortcut method. So I already have a video regarding integration by parts, but that is the long method that uses the formula UV minus the integral of VDU. So for today's video, I'm going to teach you the tabular method of integration by parts. So let's get started. Okay? So for this example, integral of 4x cubed minus 9x squared plus 7x plus 3 multiplied by e raised to negative x dx. How do we integrate this? Okay, as you can see in our first term here, or first product here, we have a polynomial function and we have an exponential function. Okay, so the rule is still the same. We're going to choose u as our priority liate. Okay, logarithmic, inverse, algebraic, trigonometric, and exponential. So in this case, what are we going to do is, we're going to choose u as 4x cubed because that's the rule, plus 3. And our dv, of course, is e raised to negative x. Okay, excluding the dx first. Tabular method uses both derivative and integral. Okay, if you are going to integrate this by the long method or by the formula uv minus the integral of vdu, you're going to have 3 integration by parts, okay, because of the power, third power, okay? But in this method, I'm going to show you that we have a u here and we have a dv here. What are we going to do is to continuously differentiate the u and integrate the dv. Okay, so let's get started. So first, if we differentiate u, okay, we're going to have 12x squared minus 18x plus 7. Differentiate again, that would be 24x minus 18. Differentiate it again until it becomes 0 or until it becomes the same as this. Okay, but that would not happen. Okay, so later on we'll be discussing that. So we have 24x minus 18, the derivative of that is 24, and we have 0 here. Okay, so we get the derivative of this u, continuously get the derivative of this u, and we're going to get the integral of this. So if we're going to get the integral of this, negative e raised to negative x, okay, integrate again, we have e raised to negative x, okay, integrate again, we have negative e raised to negative x, and finally integrating it again, e raised to negative x. So here's the catch, okay? So we have, again, the u differentiate it all, and the dv integrate it all. So we have to follow a sign convention such that the answer is, if we are going to multiply this, okay, multiply this by this, that would be a positive. Multiply this by this, that would be a negative. That's the sign convention. Multiply this by this, that would be a positive, and multiply this by this, that would be the sign convention. So how do we get the answer? The answer is simply what? Okay, the product of this, and applying the positive. So if I'm going to apply the positive here, the product of that is 4x cubed minus 9x squared plus 7x plus 3 multiplied by this, negative e raised to negative x. I'm going to multiply positive both onto them. So it would still yield to a negative. Okay? Then the next thing is minus because of this. Okay? Minus. Okay? This one, 12x squared minus 18x plus 7 multiplied by, again, this one. So that is e raised to negative x. And again, plus, because of this, right? Plus 24x minus 18, this is that term, multiplied by this, right? Negative e raised to negative x. And finally, minus, okay, 24 multiplied by e raised to negative x. So 24 e raised to negative x. Okay? So if I'm going to simplify this, this would be negative e raised to negative x, 4x cubed minus 9x squared plus 7x plus 3. Okay? And I have here negative times this negative, or this value or this term, e raised to negative x multiplied by 12x squared minus 18x plus 7. Okay? And this one, negative e raised to negative x 24. Okay? 24. This is negative times positive would be minus. Okay? 24x minus 18 minus 24 e raised to x. Of course, plus c. We have integrated it already. Okay? So what will happen here? I can factor out negative e raised to negative x. Negative e raised to negative x. So if I'm going to factor that out, negative e raised to negative x, that would be 4x cubed minus 9x squared plus 7x. Okay? Plus 3. Okay? Of course, this would be a plus. Okay? This would be a plus. Because this is a negative. I factor out the negative. This should be a plus. Plus 12x squared minus 18x plus 7. Okay? And I factored it out also, negative here. So that should become also plus 24x minus 18. And this is a negative e raised to negative x. So that should be, okay? That should be a negative also. Or positive, I mean positive. So positive 24 plus c. So I factor out negative e raised to negative x so that we have this uh, polynomial. So we have negative e raised to negative x, simplify, 4x cubed. Is there any other cube raised to cube here? None. So we have 4x cubed. Negative 9x squared plus 12x squared, that is 3x squared. Okay, don't have any other. Plus 3x squared. Okay, plus, let's say 7x minus 18x, that is negative 11x, plus 24x, that is plus 13x. Okay, and finally, the constants, we have 3 plus 7, that is 10, minus 18, that is negative 8, plus 24, that is plus 16. Plus, of course, c. And this should be our final answer for our integral above. Okay? Okay, let's go now to our second problem. Second problem here is number 2. Okay? Integral of x raised to 4 multiplied by e raised to negative x dx. So again, we're going to have a table of u and dv in here. Whereas, in this problem, we're going to choose u as x raised to 4 and differentiate it until it gets 0. So we have 4x cubed, 12x squared, 24x, 24, then we have 0 here. And we have e raised to negative x here. Integrate negative e raised to negative x. Integrate again e raised to negative x. And so on and so forth. This is alternating. Okay? And again, we're going to apply the sign convention. Okay? You start here with this. That is a positive. You start again here. Alternating sign, minus. We have here plus. We have here minus. We have plus in here. So what will happen is if we are going to write our answer, we have what? We have to, again, multiply this and applying the sign. So we have x raised to 4, negative e raised to negative x, that is a plus here, even though I did not write, that is still a plus, minus, that is that minus, the multiplication of 4x cubed multiplied by e raised to negative x. This one, and another one, we have plus 12x squared multiplied by negative e raised to negative x, okay, minus 24x multiplied by e raised to negative x, and then finally we have plus 24 multiplied by negative e raised to negative x, plus 24 multiplied by negative e raised to negative x plus c. Okay? If we're going to do that, we have negative x raised to 4e raised to negative x minus 4x cubed e raised to negative x minus we have 12x squared e raised to negative x. And we have minus 24 e raised to negative x. We have, okay, 24x, I mean. Okay. That is a 24x e raised to negative x minus 24 e raised to negative x plus c. Okay? And we can factor out furthermore the negative e raised to this negative e raised to negative x. So if I'm going to factor out negative e raised to negative x, that should be x raised to 4 plus 4x cubed plus 12x squared plus 24x plus 24 plus c. And this should be our final answer. Look, if you are going to do this with a traditional integration by parts, you would be actually finding that you would have to perform integration by parts 4 times. Okay? So which makes the process tedious. So now let's proceed with number 3. Of course, we have the integral of x cubed plus 2x minus 1 cosine 4x dx. And we're going to choose u as the x cubed plus 2x minus 1. This is x cubed. And our dv should be cosine 4x. And we have to differentiate this. And again, integrate this. So we have 3x squared plus 2. Okay? We have 6x. We have 6 and then 0. For this, if we integrate cosine 4x, that would be 1/4 sine 4x. Integrate again. So we'll be having 1 over 16. Integral of sine is negative cosine. So we have negative 1 over 16 cosine of 4x here. And again, if we integrate this, we multiply this by 1/4 again. Negative 1 over 4 times 16 is 64. Sine of 4x, still negative because the integral of cosine is positive sign and we have a negative here, still negative. And again, integrating this, we have positive, okay? Because the integral of sine is negative cosine, so negative times negative would be positive. 64 would be multiplied by 1/4 again. 1 over 64 will be multiplied by 1/4, so we have 1 over 256. And then cosine of 4x. Okay, and again, applying the sign convention we have here, this is plus, and this is minus, this is plus again, and this is again minus. So, if we're going to rewrite our answer for this in problem should be, what? We have 1/4 multiplied by x cubed plus 2x minus 1 sine of 4x, okay? Minus, okay, or this is a minus 1 over 16 of the 3x squared plus 2, then cosine of, okay, cosine of 4x. So take note that this minus sign is this, and we have a negative 1 over 16 here, so this should become plus. Okay, so that should become a plus now. And then this one plus this one, 6x, okay, multiplied by negative 1 over 64, okay, sine 4x. And then lastly, we have negative 6 multiplied by 1 over 256 cosine of 4x plus c. So if we're going to simplify that, that should be 1/4 x cubed multiplied by x cubed plus 2x minus 1 sine of 4x, okay, plus 1 over 16 3x squared plus 2 cosine of 4x, okay, minus 6 over 64. 6x over 64 can be rewritten as 3x over 32, lowest term, okay, sine 4x, okay, and lastly, we have negative 6 over 256, that is, lowest term is negative 3 over 128 cosine of 4x plus c. And this should be our answer for this problem. If you want to simplify further, it's okay. You can factor out cosine and sine, but I would leave it as it is. Okay, that should be our answer. So let's try to solve again for number 4. Number 4, the integral of e raised to 2x sine of 3x. And we have dx here. Okay? So again, we're going to choose our u and dv. U and dv. As we can see here, we're going to choose, our priority of choosing u is sine of 3x. Okay? Sine of 3x, and our dv is e raised to 2x. Okay. So, differentiate this. We know that this sine 3x will never reach 0. Okay? Because if we get the derivative of this, let's say, let's try to get the derivative of this. Sine 3x is 3 cosine of 3x. If we get the derivative of this, derivative of cosine 3x is negative 3 sine 3x. Okay, so we have negative 3 times 3, negative 9 sine 3x. And if you furthermore get the derivative of this, you will never arrive at 0. So, when will you stop? When you reach this sine 3x as the same as this, you can now stop. Okay, and we integrate this. So, the integral of this is 1/2 e raised to 2x. Integrate this again. This is 1/4 e raised to 2x. Okay? So, and apply the sign convention. So, we have to apply that. Positive and minus. And since we stop here, okay, we'll be having another line here which is a positive also. Okay? So, as you can see here, we stop at here because sine 3x is appearing in the integrand. When that happens, you must stop. And you're going to, again, okay, multiply these two. But as you can see here, sine 3x and e raised to negative 2, e raised to 2x is also present at the integrand. So what will happen is that this, if we're going to write this, okay, 1/2 e raised to 2x, I'm sorry, let me just rewrite. So 1/2 e raised to 2x sine of 3x, okay, that's the first, minus 3/4, okay, minus 3/4, e raised to 2x cosine of 3x, then plus what? Plus the integral, okay, since we stopped here, okay, we will be having an integral. The integral of negative 9 over 4, negative 9 times 1/4 is negative 9 over 4, sine of 3x multiplied by e raised to 2x, okay, plus c. Okay, that's clear because this would never get to 0. Okay, and the rule is if you arrive at the same integrand, sine 3x, whether there is a constant here, it does not matter. So, you will be integrating it again. You will multiply this but with an integral sign. Okay? So, if we are going to rewrite this, this should be 1/2 e, this should be 1/2 e raised to 2x sine of 3x minus 3/4 e raised to 2x cosine of 3x, okay? Minus, I'm going to let this outside of the integral because that's a constant. Integral of sine 3x e raised to 2x plus c. Okay. And we, again, arrive at this. So, we have already arrived at the very same given in our integral. So, what will we do? Let me just rewrite. What is the left side of this equation? Okay, what is the left side of this equation? The left side of that equation is this integral. Agree? Because we are trying to find the integral of this. So, if I'm going to rewrite that, our left side of the equation is integral of e raised to 2x sine of 3x dx. Okay, we have dx here because you haven't still integrated that. Okay, is equal now to 1/2 e raised to 2x sine of 3x minus 3 over 4 e raised to 2x cosine of 3x minus 9 over 4 integral of e raised to 2x, okay, sine of 3x dx plus c. Okay, so what will happen is that if I'm going to transpose this term on the other side, we will be having integral of e raised to 2x sine of 3x plus 9 over 4 integral of e raised to 2x sine of 3x. Okay, I forgot the dx. We have the dx here, and this is have the dx. So 1/2 e raised to 2x sine of 3x minus 3 over 4 e raised to 2x cosine of 3x plus c. So what will happen if I can factor out the integral? So integral of e raised to 2x sine of 3x dx multiplied by, if I'm going to factor this out, this because it's common, 1 plus 9 over 4, okay, equals to 1/2 e raised to 2x sine of 3x minus 3 over 4 e raised to 2x cosine of 3x plus c. So, what will I do? Simplify this. I'm going to simplify this. E raised to 2x sine of 3x dx. So, 4 times 1, that's 4, plus 9, that is 13 over 4, is equal to 1/2, the same, given on the right side of our equation. Okay, let me just rewrite. So, what will happen here is I'm going to divide both sides of the equation. Okay, I'm going to divide both sides of the equation by 13 over, or by multiply both sides of the equation by 4 over 13. So if I'm going to divide that, obviously, this would cancel. Okay? 4 over 13. So we are left on the left side of our equation, integral of e2x sine, okay? This is not inside the integral sign, okay? This is not inside the integral sign. This is a constant, so might as well I'm going to write this here, okay? 13 over 4, okay? So this is a constant. So what happened is that our constant is cancelled. So we are left on the left side of the equation as sine 3x e raised to 2x sine 3x dx, okay, is now equal to 4 over 13 multiplied by this. So we have 4 over 13. So we have what? 4 over 26 e raised to 2x sine 3x. And we have negative 12 over 13 times 4. 13 times 4, that is 52. Okay, e raised to 2x cosine of 3x plus, still, if you multiply this on the c, that is still ac. So if we get the lowest term, okay, if we get the lowest term of this, so we have 2 over 13 e raised to 2x sine of 3x, okay, and if you get the lowest term of that, negative 12 over 52, that is negative 3 over 13, okay, e raised to 2x cosine of 3x plus c. And that should be our final answer for this problem. As you can see here, our u that we used here is not able to arrive at 0 even if we differentiate it. So what will we do if this u appears again as one having in our given, just like sine 3x, and we have sine 3x here, you're going to stop differentiating. Okay? And you're going to multiply this, whatever the value of this, and get the integral. Okay? So that's what we did here. So that we arrive at our answer, 2 over 13 e raised to 2x sine 3x minus 3 over 13 cosine 3x plus c. Okay? So I hope you have fun in learning this subject matter. So thank you so much for listening. This is integration by parts by tabular method or the shortcut method. Thank you so much and God bless.